So we've got 5 to the power 2x minus 5x equals 0, sharp. Then you can take the 5 to the right-hand side, okay? And as I said, from grade 1, 2 to the power empty box equal 2 to the power 3. What's missing in the empty box? It is 3. The only way that these two sides could be equal, because this means equal, right? So the only, and then this is equal to that. So therefore, for the only way these two sides will be equal is if what's inside the empty box is also 3. So, but in matric or grade 11 or whatever high school, instead of them putting an empty box, they put an x. So then the bases are the same, you just equate the exponents. Okay. Similarly, the bases are the same here, we just equate the exponents. 2x equals x. You take the 2 to the other side, becomes 2x minus x equals 0. Then 2x minus x is just x equals 0. So that's your answer. A different approach could have been you factor out 5 to the power x. Okay. Now, why am I factorizing like that? Because if I go this times this, I'm going to get 5 to the power 2x. This times this, I'm going to get 5 to the power x. So now you've got two numbers. You're multiplying two numbers, you're getting an answer of 0. That means either the first number equals 0 or the second number equals 0. Then like 5 to the power x equals 0. There's no way that you put like it is no number that you could put here in place of x and get an answer of 0. It does not make sense. If you put 0 there, you get a 1. If you put a negative 1 there, you're gonna get 1 over 5. So there is no, so it does not exist. And then this one, if I take the 1 to the other side, let's see what happens. I've got 1 there. I could change the 1 to 5 to the power 0. Then the bases are the same, we equate the exponents. So therefore x equals 0. Those are the two methods. Happy with the two approaches? Yes? Yes, yes. Oh, if they say 5 to the power 2x minus 5x, then plus like this again. Now, do you understand or 5x, this 5x, when you put it squared, it gives you, if you put squared, it gives you 5 to the power 2x. Do you see that? So if you look at this thing closely, it's in the format x squared minus x plus 15 equal to 0. So this is like our x, and then this is like our x squared. Do you see? So in this instant, we use the quadratic form. In this instant, we normally use the quadratic formula. So now what you're going to do in this sort of situation, you're going to go, let k equal, let 5 to the power x equal k, and then you have k squared minus k plus 15 equals 0. And apply the quadratic formula and have k equal minus, my b is minus 1, my my b again is minus 1, like this. Right? This will give you answers. Let's quickly punch. Let's all punch and see what we get there. Let's make it positive. Let's say this was positive. Let's make this negative. Let's make this negative, so that we don't get an error. Yeah, make this 15 negative there. This will give us 4.41 and minus 3.41. Okay, it gives us those two answers. So what you're gonna do is that the first answer is k equal to that, k equal to that. So you're gonna go k equal 4.41, right? You place the k with the 5 to the power x equal 4.41. Ne? So unfortunately here you're not able to convert this to 5 to the power something, so you're going to use logs. So how to use logs? You want to remain with x alone. You don't want to have x at the top and have x at the bottom. You put it down like this. It pushes the 5 to the other side. The other 5 becomes the smaller than a 5 that side, and have 4.4 there. Log 4.41. And then you punch into a calculator. If you had k, if your answer was, for example, k equal to 25, then it would have been easy. It would be 5 to the power x equal 25. And we know that 5 is the same as 25 is the same as 5 squared, then therefore your x will be equal to 2. But if in the case of something like this, you just do that, you do the same with that. Are you are you happy with that?